The types of projects which are amenable for precasting is the ones which are repeatable. The ones which are repeatable. Before we go into that, I just want to go very quickly into some of the points which we are very familiar with. Last class we were looking at some of the design consideration. If you are going to design a precast or prefabricated unit, these are the points which you will be looking at. First and foremost is the jointing. What type of jointing you are going to have? Whether it's just going to sit on something, whether you are going to bolt it to something, or is it that there's going to be a notching system which will not prevent it from moving around. Second thing is the capability of your casting yard. Is your casting yard capable of handling such a huge element? Or if suppose you are going to go for a small element, you may find that you are finding a trouble in loading the element or storing the element. Okay. Then the other important thing is the transport consideration. How big or how big can you go? Depends on the type of transportation which you are going to be using. Then the other important thing is handling and placing. What kind of equipment are you going to use in handling the element? Is it going to be one crane or two cranes, or what would be is there going to be some other derrick mechanism? Whatever you are going to think of, all of that has to go into your planning stage itself. Otherwise what happens, you may have done a lot of work, end of the day you are not going to be able to place it in position. And finally, it is this modularity and standardization. Are you going to be able to get a standard pattern? Okay, where you can keep reusing the mold, where you can keep the, like, you know, where you have the where you have things in a standard fashion. When you say standard, it will all look the same, and you can all handle it the same way and stuff like that. And again, profit in a precast system is only by numbers. If you are having more number of elements which you can precast with the same kind of mold or same kind of handling, what would you like to share, please? You have something to say? See, precasting is a very common thing. Many of you would have seen precasting in action, and I welcome, if you want to share something, share it to the whole class. Okay, so profit in a precasting system is only when you are able to do it in large numbers. Please remember that the metro rail and all these things have a very constant shape of the viaduct. That is why we are able to make a profit there. Okay. So these are some of the things: structural, non-structural and volumetric elements. What is a structural element? Anything which carries load. Please remember, this is just like in your CAT 1. CAT 1 we asked what is physical, chemical, what are physical and mechanical properties, right? So like that we divide all our elements into structural, non-structural and volumetric components. What is a structural component? It takes a load. It transfers the load from one point to another point. Okay. So essentially you are sitting or we are all sitting on this floor. Where does all this load go? It all goes to the ground, right? Through structural elements. There are other elements which are non-structural. What is the work of this wall, or what is the work of this blackboard or this lectern? It actually essentially does nothing. It doesn't do anything in terms of carrying the load. It is there for some functional reason only. For example, your windows, your doors, they are not playing a role in transferring forces, but without them you are not going to have a structure. So those are called the non-structural elements. The last thing is the volumetric elements. See, volumetric elements can also be prefabricated. How many of you know modular kitchens? See, it's a volumetric element. It's a volumetric element which goes and fits into the space. Okay. So anyway, maybe I should have gone through this slide. So these are the volumetric structural elements. Do you have any problem with any of them? What are corbels? Corbel is a projection from a column on which you keep heavy loads. If you go to CDMM building, in the ground floor there is a lift, there is a crane. How many of you have seen the crane in the CDMM building? Okay. How is it running? It's running on two steel beams. The steel beams rest on a projection from the column. That is called as a corbel. Okay. You can see corbels in many of the old construction for supporting the roof and things like that. But nowadays corbels are restricted to applications like what we have in our CDMM building. What is a lintel? What's a lintel? Lintel is the structural element which is placed over the window. It carries the load of the bricks above it. So it becomes a structural element. Okay. The load of the bricks cannot be supported by the window. There is a beam which runs called the lintel. Okay. So that's called the lintel. Other things I think you will know. Facade is nothing but what is put in the front part. Okay. Just to as a decorative element. For example, you go to MGR building. In the front we got a glass in a curved fashion, right? So that sort of things are called facade. Decorative fins, please go to SJT. On top of SJT, you will notice that there are some elements which are protruding. Which are just what is the use of that? Nothing, just a decorative bit. Okay, or even sometimes they'll keep fins on walls where it just projects out. So these all can be very successfully prefabricated. So this is again another thing which we were talking about. So I am not going to go much into this. Now, these are the types of projects which you can prefabricate. These are the types of projects which you can prefabricate. Basically, you can do the residential, industrial, infrastructure and commercial buildings. Okay. So residential where you live, industry where you have some kind of production done like an industrial shed. All this can be done with the precast thing. What is infrastructure? Roads, railways and stuff like that. Okay, so you will find that precasting is very common in this particular area in India. Okay, so I have a short video, but I will play it at the end of the class. Okay, because I got quite a lot of things to tell you. Okay. Okay, so India has a code for the precast units. Okay, I am just opening that code. It is IS 15916. IS 15916 is the code which is used for. Okay, this is the code which is used for precast units as per the Indian standards. Now, I am going to go through this code. Okay, if you don't know how to read a code, this is a good chance for you to go through it. Okay, see, basically any code is referred by the number. Okay, you can see it everywhere. If you see your gas at your home, the gas stove has an IS number. So these are some place your water heater has IS numbers, and in which year it has been published. Usually what happens is you may have something called reaffirmed. Reaffirmed means after 20 years they still feel that the code is worth continuing with the same wordings. Okay, typically every code will have some corrections. So these will be issued periodically by the Bureau of Indian Standards. Okay, so in India we have the Indian code. Now please look, all the terminology which is there, which is used in the code, is given in the first part. Okay, always this terminology is the first part of a code. Okay, so in this one, maybe the sandwich reinforced concrete panel is something you might not have heard. What is this? A sandwich panel is nothing but where you have more than one panel with some medium in the middle. Usually it is insulating material. Usually it's an insulating material, and self-compacting concrete doesn't need any vibration. It will flow into place and then it will be compacted. Shear connector is a very important term. See, usually in many of the construction they will keep a steel element which is prefabricated and brought into place. So then they will pour concrete on top of it as a decking. Decking is the place where somebody can walk or where a vehicle can move. So to ensure that there is a good connection between the concrete and the steel, we use the shear connectors. Okay. So other than that, you please just go through this. Now remember that we have some criteria for selecting materials. The whole thing is put in this code book itself. The entire thing is there in the code book. Then you have the other details. We are talking about plans and all those things, right? All of them are here. All of them are given here. And if you feel that you have any doubt after going through this code in light of our lectures also, please feel free to ask. So all the components, whatever are done, for example, flooring and roofing scheme, what is the length, what is the width to which you give, all of them, all of those things have been standardized. And above all, see this table, it gives the product tolerances. This gives the product tolerances. Remember, we were talking that tolerances will be given in brackets as a plus or minus dimension. So if you are doing it according to India, this is the tolerance which has been given for various elements, including how much it can be twisted, how much flat it what is flat, what is the definition of flat. All of these things have been given here. Okay, maybe this lintel and chaja is nothing but sunshade. Okay, chaja, there is one word which is given here. Chaja is nothing but sunshade, and all the units, all the various kinds of units which can be done is also given here. All the various kinds of units is also specified here. Okay. We were talking about design considerations, right? The last class. Now, if you look at this code, they are also giving the specifying the design consideration. Maybe they are using some other extra words. Okay, like it should be strong enough. It should also be stable enough. Okay, it should also take into account all the handling stress. Of course, you understand what stable is, I am sure. Okay. One very important thing is probably something which we didn't touch earlier. It is this progressive collapse. What is progressive collapse? If one element collapses, the entire system should not collapse. The entire system should not collapse. Such a thing is called a progressive collapse. Okay. See, for instance, one of the World Trade Center towers collapsed almost very quickly after the attack. Okay, such a collapse is a catastrophic collapse. It just collapsed. The building just was destroyed in a very short period of time. So that is not permitted. So when you are designing itself, what they try to do is, if suppose an earthquake load comes, probably these elements can fail. So like that, they will have a load path which they determine in the initial stages itself. So what all can go, what all should not go. Okay. So these are some of the way the loads have to be taken. Maybe you will not be able to appreciate that very much. However, the other things are fairly straight. Okay. The other thing is the joints. Okay. What are the requirement for joints? That is also here. Okay. And all the tests which you have to do for the various elements is also covered in this code. Okay. So by and large, if you look at it, there is a lot of other things also which you will find that is an extension of whatever we have gone through. Okay. So please make a note of this code, IS 15916, IS 15916. This is the code book which you are going to be using to demonstrate that you have understood prefabricated construction in your, even in your CAT exam. Okay. So I will just I'd just like to show you one. Okay, I just like to show you this particular video on the stages of construction of precast elements. ensures that all the elements are kept with the correct spacing. So cover should be there, space between the steel and between the steel reinforcement and the atmosphere. Okay, that's essentially cover. This is the compaction. Okay, the concrete has to be compacted to ensure that there are no voids. Okay, and then they are also going to rotate the element. Can you see now the difference of the way the concrete is from what it was when it was initially kept? The cement paste is just floating up. Okay? This is called latience. What is floating on top is latience. And this is the way you are expecting. That is the sign that your concrete has been fully compacted or vibrated. Can you see this is a continuous operation? People on the other side are starting to do the initial stages, okay, of what was done on this slab. Fine. So I hope you found it informative. All the steps which are there are common for most of the prefabricated works. If it is not this, they'll have a sponge system where they just put the concrete, spin it, and then you can make the shape of pipes, the shape of poles. Okay, in fact, in the last project which I was working on in the industry, we used what are known as spun piles. Okay, it was just because of the centrifugal action, it will be made into the shape, and then it's just allowed to cure, and it comes to site. They hammer the pile in place, and it forms a foundation. Okay, so I hope you found this informative. So basically, the one more point, the slide got deleted. Who are the people who are stakeholders, or who are all the people who work in a precasting system? Okay, the people who work in the precast system are, okay, first and foremost, the of course it's the owner. Then there is the design. Okay, many of the things, did you notice that the number of items which have been standardized? India has standardized. Countries like Hong Kong and Singapore, they all have very good standards, okay, for precast and prefabrication. So you have many of the things standardized. Some of the things are not standardized. However, if it warrants, you can have a precast, you can modify your precasting system to accommodate it. For example, you are getting the contract for doing all the precasting for the entire metro rail in Chennai. Okay, you are going to do some tens of thousands of individual elements. It is worth investing in a modification of your plant. Okay, you will have the other things. You have the batching plant, you got standards for material, everything. Only thing is that mold, how best it is going to be done. See, did you see here? They have a CNC robotic arm to make the marking. It's not done by human beings. If you and I have done it, can you think how it would have done? We would have either had a template, or we would have had to measure it every time. But here it has been programmed once. So if suppose you are going to program for each and every element, then it is not worth it. That time it's not going to be economical. Okay. So then design people will have to see what is the capability of the yard, what is going to be the transportation, etc. Whatever I was talking about earlier. So the design team plays a very important role. Then the people who cast these units, those who are working there, whom you saw in the video, those who kept the machinery running also. So they are the other people who are involved in this. And beyond these people, we also have the people who transport these elements and those who place these elements in position. So these are the people who will be working in a typical precast or prefabrication projects. Last but not the least, there are the people who have safety department. What is the work of these people? They have to ensure that there are no accidents, whether the tolerances or whatever is the checklist which has been given, whether people are looking into and stuff like that. Okay. So with this we will stop this lecture for today.